Welcome to the Universal Robots Virtual Automotive Factory, where we will explore 24 cobot work cells in a variety of processes. Our Automotive Virtual is actually four factories, one molding and processing plastic parts, one building tier automotive components, the third building powertrain components, including EV battery packs, and the fourth assembling and testing seat assemblies in an interiors plant. The factories showcase various cobot applications common to the automotive sector. A reminder, clicking on each cell zooms into the cell details, including links for videos, case studies, and more. So let's move to our first cell. The first cell is in the plastics factory, and it features a UR20 unloading and injection molding machine that is making engine compartment fan cowlings. The UR20 utilizes a multi-point vacuum gripper to pull the finished part from the mold and place it in a magazine. The UR20 is perfect for this class of application, offering the reach and precision required for larger parts or multi-cavity molds. In this configuration, the UR20 is mounted on a mobile cart, so it can be moved from machine to machine depending on the production plan for the day. Full magazines will be transported to the next step in the manufacturing process by a mere AMR. Next, we'll move on to a fan cowling assembly cell. This is a dual robot cell featuring a UR20 for material handling and a UR30 for clip insertion. Individual parts enter the cell via the mere AMR. The UR20 with a dual gripper unloads the finished cowling and places it on the AMR fixture, then places a blank onto the clipping fixture. The UR20 was selected due to reach and payload requirements of the application, and it picks up an array of clips in a dedicated end-of-arm tool specifically for clip insertion, and then places them onto the cowling. The clipping fixture tilts to make insertion easier, all under the control of UR's Motion Plus software. The UR30 was selected based on the payload of the insertion tool and the stable, rigid positioning required during the insertion process. Next, let's move to the fan cowling quality control cell. In this application, a UR20 is manipulating a vision laser sensor from the UR Plus marketplace over the geometry of the fan cowling, checking for proper placement and engagement of the clip assemblies. The UR20 is invert mounted to maximize the work envelope in the overall inspection area. Assemblies are delivered by mere AMRs after the assembly process and can be inspected while in the insertion fixture. Now let's jump over to a headlamp assembly, also in the plastics factory. In this station, a pair of UR10Es are assembling front headlamp assemblies. The first robot does the material handling tasks, picking the lower case and placing it into a fixture, then picking the upper case and placing it on top of the lower case. The second robot uses an auto-feed screwdriver system to insert 3 screws into the assembly. The first robot then places the finished headlamp on an exit conveyor. Higher speed production could be achieved by adding a second fixture, allowing more simultaneous motion by both robots, and the highest production rates could be achieved by adding a second fixture and 2 additional cobots. Don't forget to check out cobot screw-driving solutions from UR partners on the UR marketplace. Now we're going to move over to a tier component plant. And the first application we're going to look at is shock absorber testing. In this station, a UR10E is loading and unloading a pair of shock absorber test machines. Untested parts are delivered by a mere AMR. As parts are tested, they're returned to the cart, and the full cart is then moved to the next process step. The UR10E is equipped with a dual gripper to increase throughput and productivity. An untested shock is carried to the tester. The dual gripper then removes the tested shock and loads the untested shock into the testing machine. Meanwhile, tester number 2 is completing its test cycle, and after dropping the finished shock from tester number 1, the UR10E starts the cycle over again. Maximizing throughput in multiple station cells requires a thorough understanding of takt times for each process to avoid lower productivity or investing in underutilized automation. The next application we're going to look at is instrument cluster embossing. In this station, a UR10E is used to load and unload an instrument cluster onto a dial table embossing cell. A blank instrument cluster is delivered via a vertical magazine, and the UR10E picks the blank from the magazine and places it into a tooling fixture on the 6-position dial table. After embossing, the instrument cluster is inspected. then placed on a conveyor that feeds into a curing oven. Cobots offer a great deal of flexibility over hard automation and dial table applications, capable of adapting to various product sizes and shapes. Still in the tier component factory, our next application is exhaust welding. In this cell, a UR10E is MIG welding exhaust system assemblies. This is a demanding application due to the nature of tube welding in general and the compound geometry of the assembly itself. Cobot arc welding on light gauge steel requires precise control of the motion and weld control parameters. The ability to control external positioners via UR's Motion Plus software enables the complete assembly to be welding in an optimal position throughout the cycle. The example shown is a low volume cell where an operator must remove the finished part and load a blank weldment while welding is paused. Higher productivity could be gained with the addition of a second positioner. The UR10E is an ideal fit for this application. However, larger weldments can be handled with the expanded reach of the UR20. While this application shows MIG welding, UR partners support TIG, laser, spot, as well as plasma and oxyacetylene cutting. Next application we'll look at is CNC machine tending. In this application, we have a pair of UR20s tending front-load horizontal mills. The UR20s are equipped with dual grippers to maximize spindle on time and increase productivity. A finished part is unloaded and a blank is loaded into the chuck in one process step. Both UR20s are mounted on mobile carts, allowing the cobots to be moved from machine tool to machine tool with maximum flexibility to meet daily production plans. Blanks are delivered and finished parts transported to the next process step via mirror AMRs. The UR20 controller manages all cell logic, including part present status, gripper status, door open, spindle on, and more. The UR20 was selected to meet payload requirements and for larger work envelope to support larger machine tools. Still in Powertrain, let's move over to an EV battery assembly station. This cell in the Powertrain factory utilizes 6 UR30s for the assembly of electric vehicle battery packs. 2 conveyors deliver individual battery cells, which are oriented and placed into the battery pack frame by 2 UR30s. The populated frames are fed downstream to 4 UR30s equipped with high-torque, self-feeding screwdrivers to attach the cells to the frame. Note that the middle pair of UR30s actually start the assembly process on a new frame, while the previous frame is being completed by the final pair of cobots. This flexible setup allows different frames and better battery cell configurations to be run on the line. The UR30s were selected in this application for their payload, up to 35 kg depending on wrist orientation. Now we're going to move over to a Powertrain factory. And the first cell in the Powertrain factory is for sealant dispensing on a transmission case. Transmission assemblies minus the cover are delivered via an indexing conveyor to a UR10E dispense cell. Sealant is dispensed into a channel on the front of the transmission case. Sealant volume is tightly controlled based on the speed of the dispensing tip to ensure proper fill and no overfill. After dispensing, the transmission is inspected in a machine vision cell to ensure proper sealant coverage. The UR10E was selected based on reach and payload. Larger assemblies might be better suited for the UR20. Next, we'll look at transmission case assembly. So immediately following the sealant dispensing, the transmission cases enter a 3-robot cell for final assembly of the case cover. Covers are delivered via an indexing conveyor and are placed on the transmission cases by a UR10. The transmission cases then index to a high-torque screwdriving station equipped with bulk feeders, where a pair of UR30s complete the assembly. The UR10E was selected based on reach and payload, and the UR30s were selected for their payload and ability to handle the high torques generated by the screwdriver. Now we're going to move into the last factory, and this is an interiors factory, and we're going to start off with automotive seat assembly. The first application is for the assembly of seat backs to the seat bases. Bases and backs are delivered on indexing conveyors. A single UR10E picks up a seat back and aligns it with threaded inserts on the seat base, holding it in position. A pair of UR10Es then complete the assembly attaching the seat back with threaded screws from a self-feeder. UR10Es were selected to meet the reach and payload demands of the application. Bigger or heavier seat assemblies might require the UR20. Also note, throughout these demos, anytime you see a link for more information, you can actually click that link and be able to download a whole series of information, including case studies, technical notes, and videos. Now let's go to the final application, which is seat testing. The final application is for quality control of the seat assembly. The finished seat assemblies are delivered via an indexing conveyor. In the first step, a UR10E picks a snap fit cover from a magazine and places it over the hinge area on the seat. In the next station, the seat is locked in position and powered by a bus bar system extending up from the interior of the conveyor. The UR10E then mechanically engages the manual seat controls as a driver or passenger would, and the vision system validates the motions and proper operation of the controls. The bus bar detracts and the finished tested seat is released. Thank you for visiting the UR Virtual Automotive Factories. We hope you found this session valuable.